Okay, so we're talking about subtraction using the chip model. Okay. Now, when we had the addition algorithm and we were modeling the addition algorithm using the chip model, honestly, you can put the things in any order that you want. Okay, if we go back and look at the example we just did, okay, we put in the 2 and the 7 first because that was on the top, and then the 3 and the 5. You could have flipped those, that would have been fine. The key thing is we end up with 12 here, and we have to take 10 of those and trade them in for an additional chip here, and then we end up with 6 here. Okay, but you can do things willy-nilly in the addition algorithm. With the subtraction algorithm, you got to be really careful. Okay, so let's try a fairly simple one. Let's do 45 minus 23. Okay, now I have to start with the 45. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Now, what do you think I should do to illustrate the operation of subtraction in this chip model? How can we get a picture of taking stuff away?
Mark them out.
Right, cross them off, okay? So we got 5 ones, we want to take away 3. 1, 2, 3. We got 4 tens, we want to take away 2, take those away. And now we can see our answer here. We're left with 2 in each tray. So 2 in the tens tray, 2 in the ones tray, 22, okay? Easy. Okay, I want you to come up with a 2-digit problem that I can do here, a 2-digit subtraction problem that would involve unbundling. So how would we create such a problem? What would force me to have to use unbundling or borrowing?
$351 minus 232.
Okay, so 351 minus 232. Okay, let's make it a 2-digit problem. So let's just do 51 minus 32, okay? So why did you make this choice here? Why did you decide to make that a 1 and that a 2?
You can't subtract 2 from 1 without borrowing.
Okay, right. So the idea is in the ones place, we want to have a situation where we have to take away more ones than we have. Okay, now note that we could not do something like this. What's the problem here?
The number would be negative.
Right, we're talking about mathematics that we would be teaching in primary schools. Okay, this doesn't work. Okay, you're allowed to have this number here bigger than what you have up top, but not over here. Okay, So just something to keep in mind as we go. All right. So let's see. We start the same way. Okay, we start by loading in the 51. Okay, so you might want to make a note of this to yourself. Okay, remember, when we talk about these key ideas in class, these are the items that if somebody misses class, if your friend misses class and asks you what happened, this is what you want to tell them. So if they say, okay, how do I do chip model for subtraction? I know he's going to ask that on Friday's quiz. Well, you say, okay, you start with this number. You load that number into the chip model, okay? Now I got one chip, I need to take away two. I can't do that. So what do? Help me out.
You borrow from the tens place.
Okay, right. So we take one of these, we cross off one of the chips in the tens tray. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then I take that and I bring over 10 chips to the ones tray. What now?
Take away 2.
Right, we take away 2 from this ones tray, right? And think about how we write this in the algorithm, right? If I were to look at this and I wasn't thinking about the chip model, I was just thinking about the algorithm. First thing I would do, cross out that 5, make it a 4. And then I have 11, right? 11 take away 2 is 9. Look at how many chips I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this algorithm is giving us this chip model is giving us a picture of what's happening over in the algorithm. Okay, now I'm still not done with the problem, of course. What should I do here?
Cross out 3.
Cross out 3 because we're supposed to take away 3 from what we have in the tens place. We started out with 5, traded one of them, and now we only have 4. And we can see when all is said and done, there's just 1 left. Okay, so 51 minus 32 gives us 19. Okay, so remember, the whole purpose of using these models is to help somebody understand what is happening in the algorithm. You can't go the other way. You can't use the algorithm to figure out what you should do with the model. Well, I mean, I guess you can, but if you start out doing that, you want to get away from that really quickly. Okay. Remember, we want to go from concrete to abstract in the primary grades, of course. This is more abstract than this picture. The goal is to start with pictures like this and lead up to the students working the algorithm. Okay, let's go kind of a third level of difficulty. Okay, we got hundreds, we got tens, we got ones. Okay, so let's look at this. The hundreds place, the tens tray, and the ones tray. I want to illustrate this subtraction problem using my chip model. So how do I start?
Do the chip model writing 504.
Okay, so what should I put here?
5.
5. How about here?
None.
Nothing. And now what do I do here?
4.
4. Okay. So 500s, 0 10s, 4 1s. Okay, now I'm looking at this. I got 4 chips. I'm supposed to take away 9. Can't do it. I go here. I don't have anything to break up. So what do I do?
Bring 10 tens from the hundreds place.
Okay, right. So we trade in one of the hundreds chips. And over here, now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chips. Okay, now what?
Bring 10 ones to the ones place.
Okay, right. So we trade in one of those chips in the tens tray, giving us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 additional chips in the ones tray. Okay, now we can finally get started here. Okay, what would I do in the ones tray?
Cross out 9.
I would cross out 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now let's kind of keep track of this as we go here. Remember what we had to do. We had to trade in one of the hundreds chips, leaving us with 4, giving us 10 chips in this tray. All right, now we had to trade in one of those, leaving us with 9 chips in the tens tray and giving us 14 chips here. From those 14 chips, we took away 9, and we were left with 1, 2, 3, 4, 5. Okay, what next?
Take away 2 from the tens.
Okay, we're
place.
taking away 2 from the tens place, and we can see what we're left with. 1, 2, 3, 4, 5, 6, 7. So we have 7 there. And finally, what?
Take 1 from the hundreds.
Right, we take away an additional 1 here, and we can see that we are left with 3 hundreds. Okay, so every step that we do in these pictures corresponds to a step that we do in the algorithm. And the whole purpose of the model is to illustrate why this algorithm works. Okay, why it works the way it does. Okay, so in the homework, you'll get some practice doing the chip model. This is certainly something that I would expect you to be able to do on a quiz or a test, all right? So make sure you get practice with that. Okay. I want to compare something here. Let's just do a little review here. If I asked you to write this in expanded form, what would you write down? This is something we talked about a while back. We didn't do very much with it.
300 plus 40 plus 2.
Right. So basically the expanded form is kind of the way you say the word, right? You have 300s, you have 40, you have 2, 342. Okay, that's the expanded form. Okay. So this is kind of the basic review there. Expanded form is really nice for addition, especially if you don't have any carrying. Right, we can do the 300s plus the 100. We can do the 4 10s plus the 3 10s. And we can do the 2 1s plus the 6 1s. And these are all, of course, one-digit problems. So that's 478. Okay, so expanded form, very nice for addition. There can be a little bit of a problem when you're doing representations in the expanded form for subtraction. Hold on a sec. Let me get a copy of my book. Okay. So I'm looking at elementary math for teachers. I'm on page 65. And I'm looking at, let's say I'm looking at number 2. Okay. If you don't have your book with you, I'll just kind of display it here using my document camera, right? Number 2. Okay, so it says to find this, you regroup 1,221 as blank hundreds, blank tens, and blank ones. Okay, now if I were to do the ordinary expanded form, okay, let me do a similar problem here. So let me do this example. So to compute, let me do something where I'd have to borrow. To compute 834 minus 165, we think of 834 as blank hundreds, blank tens, and blank ones. Okay, now ordinarily, 834 would be thought of as 8 hundreds, 3 tens, and 4 ones. Okay, now why isn't that helpful for this problem? What's the issue? Why can't I think of it like this? Or why isn't it helpful to think of it like this when I'm doing my subtraction problem?
You can't subtract 5 from 4.
Right, right. The problem is it's telling me to take away 5 from the ones place. I only have 4 ones if I think like this. So I can't do it. Okay, but if we look at the chip model that we were just talking about, it actually tells us the appropriate way to think about this number. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 4. Right? I would have to take away 5 from the ones place. So I'd have to move some chips over by cashing out one of the tens places. Okay. Now, I would argue that there's something else I need to do even, right? Because remember what I'm trying to do. The problem I'm trying to do is 834 minus 165. Okay. So this part is great. If I have 14 ones, I can take away 5. Whereas if I only have 4, it's impossible. Now, should I do this? Should I say, think of it as 2 tens? Does that help me do this subtraction problem right here?
No, because you can't subtract 60 from 30.
Right, right. The problem is now I'm supposed to take away 6 from the tens tray. But I won't, if I only got 2, I'm in even worse trouble than what I had before. So what should I do?
Borrow from the hundreds place.
Right, we cash in one of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I should re-visualize this. Instead of 8 hundreds, 3 tens, 4 ones, I should do 14 ones. I should do 12 tens, and finally 7 hundreds. When I'm thinking of the number like this, now I can do the subtraction. Okay? And remember, this is the exact thing that we were doing in the chip model, which is the exact thing that we do in the algorithm. So you might say, well, this is kind of a silly thing to do, but this is exactly what we do in the chip model and in the algorithm. We might not say it explicitly, but it's in the background. And remember, one of the challenges when you're teaching elementary mathematics is that the topics are familiar to you. And that can be dangerous because they're familiar to you, but they're not familiar to your students. So it's important that we sit down every once in a while and we break out the details here like this. Okay, so that's what's going on behind the scenes. I want you to try this one here. Okay, I want you to try number 2 from page 65. Okay, we're doing this subtraction problem. They want to know, how should we think about this number so that we can do the subtraction problem? Take 2 minutes and try and work it out. If you need to, draw the chip model and look at what you would do to do the subtraction in the chip model. Okay, so what are we thinking here? Ordinarily, we would say it's 1,000, 2 hundreds, 2 tens, and 1 in the ones place. But if we want to do this subtraction, we should think about it a little differently. How many ones should we have?
$11.
We should have 11, okay? Why doesn't saying 1,000, 2 hundreds, 2 tens, and 1 1, and why doesn't that work for this problem?
You can't take 8 from 1.
Right, right. So in the typical expanded form, we have 1 in the ones place, but we got to take away 8. Well, if you have 1, you can't take away 8. You got to revisualize. And you would revisualize by borrowing from the tens place. If you unbundle one of the tens, that gives you 11 here in the ones place. So now you have 11 in the ones place, and you can take away your 8. Okay, so what about here? If I unbundle one of these tens, now I've only got one of them. I originally had 2, one of them is gone because I unbundled it to get 11 over here. So what do I do?
You borrow from the hundreds.
Okay, I borrow from the hundreds. So how many do I end up having in the tens place after I do that borrowing?
$11.
You got 11. Okay, remember, we're not going to have 12 because we already took away one of the tens and traded it in for 10 over here. So now we have 11 here, and how many in the hundreds place?
11 again.
Right, also 11. All right, now, if you're saying, well, how could I possibly keep track of all that? Let me show you. We're talking about 1221 minus 888. Let's go through what we would do with the subtraction algorithm, right? We got 1, we're trying to take away 8. Unbundle from the 10, you get 11. Okay, you got 1, you're trying to take away 8. Unbundle from the 100 to get 11. You got 1, you're trying to take away 8. Unbundle from the thousands to get 11. Okay, notice 11, 11, 11. Okay, when you do the standard algorithm, you are doing what this problem asked us to do. It's not some weird thing. It's something that we are keeping track of here in the standard pencil and paper algorithm. And of course, we're also keeping track of it in the chip model. Okay, so there's really not much to keep track of in a problem like this. It's just asking us to be explicit about what we're doing when we do the subtraction algorithm. So we don't think of 1,221 as having just a single 1. We think of it as having 11 so that we can take away the 8. And we don't think of 2 in the tens place. We got 11 once again so we can take away the 8. And so on. Okay. So that's how you tackle problems like that. This refers you to some primary math 3A stuff, so you should be good with that. This is a kind of problem that we saw in section 3.1. We are revisiting that problem, okay? So as a teacher, of course, your students are going to make mistakes. We all make mistakes. The thing you need to do is you need to be able to help the student understand why what they did is a mistake and how they can fix it. Okay, so let's say we have this middle problem right here, okay? What's going wrong with what Julie did?
The middle row, instead of it being a 10, it needs to be a 9.
Okay, right. Needs to be a 9 there in the middle. So what happened is Julie actually missed a step, I think. She's looking at the 5 here. She needs to take away 9. She says, okay, well, I can't take away 9 if I only have 5. So I'm going to need to unbundle something. So she eventually, it looks like she went over here and unbundled one of the hundreds. So now she has 5 hundreds, giving her 10 in the tens place. What she needed to do was unbundle one of these tens, leaving her with 9 in the hundreds place in order to get 15 over here. Okay, that's a fairly tricky part of the subtraction algorithm is what do you do if there's nothing to borrow from here in the next place over and you have to go over an additional place. Okay, so she looks like she missed a step there. So our answer would be a sentence or two explaining what Julie did wrong and what she needs to do to fix it. Okay. So for homework, I would like you to work on problems 1 through 5, 7, and 8. In other words, skip 6. Okay, so we've got quiz 5. Should be up on Canvas. If you're still having trouble, ask me and I'll try to figure out something. There is a way, it depends on the software you have, but I think the PDF, I think Acrobat Reader will let you comment on the PDF, and you can basically like put your answers in that way. If not, just write your answers on paper, scan the paper as a PDF, and upload that for your work that I will grade. Exam corrections will not be due on Thursday because I've still got your exams. The grades are posted on Canvas. I'm hoping I see you guys on Friday and I can give back exams then. If campus is open tomorrow, I will be at school and you can come and pick up your exam to do corrections. What do you say we make corrections due on Monday so that we have some time to get them done? Okay, so corrections due Monday, assuming that I can get you back your exams between Thursday and Friday. Okay. So I guess I will go ahead and end the meeting unless anybody has any last minute questions, and I'll see you next time.
I have a question.
Go ahead.
So I still need to take my test, and
Right.
so we talked about doing it virtually. Do I need to get back on this Zoom meeting whenever at 2:00, or how will we do that?
Stay on the meeting, and I'll deal with that in a sec.
Okay.
Quiz 5 says that it's part of an unpublished module that's not unlocked yet.
What? Oh, okay. Let me fix that then.
Okay.
That's weird.
You can see quiz 5 in files.
Yeah. Go to assignments, I would say. Are you trying to get it from the assignments? Oh,
Yeah, I went to the assignments.
okay. I think I've figured out what I need to do now. Let me try this. Okay, you might have to refresh the page, but I think what I just did will fix the problem.
Okay, yes, I can see it now.
Okay, so you should see the quiz module and you should see quizzes 1 through 5.
Yeah.
Okay, great. Thanks. Okay, let's see. So Raythea, do you have a printer?
Yeah, I'll probably take it at my work.
Okay.
So
okay,
yeah.
so you can print. Okay.
Yes.
Let's do that. I will create a little Zoom meeting. Log on at 2, and then we'll get you started. Okay.
Okay, that sounds good.